Alright, so before we actually can finish this lesson, we have to do two more things. So we're going to have to graph it, and then we're going to have to talk about domain and range. Again, just like we talk about domain and range with exponential and all the other functions. So with graphing, the best thing to do, and this one thing we're going to always need to do, always change the log function to an exponential function. So always change it over. That way it makes it easier to deal with when we actually have to graph it out. So here we're going to do our swoosh. Changing the exponentials to logs, or logs to exponential, sorry. So we're going to start off with our 5, and we're going to take it around town. Bring it around town. So we get 5 to the y power equals x. So we did our swoosh. Start with the base number, take it around, y is next, and then x is what it's equal to. And again, please don't make that too hard. Don't make that harder than it should be. Now with this, we're going to do this a little bit backwards from what we did with our exponential function. We have our y here, and we have that x is going to equal 5y. Now with our x values, we're going to have to find those. We're not going to know what they are. When it came to our exponential, we said our x values were -3, -2, -1, 0, 1, 2, 3. And when we graph them out, we're going to use those same numbers over and over and over every single time, so we don't have to even think about what to use or get confused and then it's all over the place and we don't know what's happening. Now, when it comes to log functions, hopefully you've heard this before, or you've heard about it before. Log functions and exponential functions are inverses of each other. So, for example here, so I can show you a visual of what's going on. We know the exponential function comes this way and it goes up. And we know a log function comes like this. Now, when it comes to inverse functions, really all we're saying is there's like a dotted line here that if we like invert it, or if we like flip it on top of that line, or cut it along that line and flip them on top of each other, they will match up exactly perfectly. So with our inverse functions, we're switching our x and y values to be able to get that. So what we're going to do here is, instead of our x's being -3, -2, -1, 0, 1, 2, 3, our y's are going to be those numbers. So we're going to do -3, -2, -1, 0, 1, 2, and 3 for our x values. For our y values. The y values. Always number 3. For our y values. Not x, but y. And just like we did before, we're going to take each one of these and we're going to substitute them in for that exponent. So here is not going to be anything differently than what we did. Really, the table just flips around. It just goes backwards this time. So on the bottom one here, we know 5 cubed is 125. We know that 5 squared is 25. We know 5 to the first is just 5. We know 5 to the 0 is just 1. Anything to 0 power is 1. And we know when it comes to our negative exponents, we flip these to make them positive. So we flip this base number here to make it a positive number. And we make it a positive exponent. So we already know that each one of these is like 5 over 1. And so if we flip it, that means we're going to do 1 over 5 cubed. And 1 over 5 squared. And 1 over 5 to the first power. And again, remember, the 3 goes to both the numerator and denominator. So I'm not going to actually do all that work. I'm just going to say 1 over 125. And we know that decimal is 0.008. We put in the calculator. And then here, we're not going to do all that work again. Just 1 over 25. And that's 0.04. And then for the last one here, that's 1 over 5 again. And that's 0.2. And so we're not really spending a whole lot of time with that because we just talked about that with exponentials. So I want to make sure that you just have that. And again, what I'm looking for is this part here. So when I look for work, I'm looking for this part. I'm looking for the answers here. So even if you do the, I want to see the fractions here, these answer fractions here, and the decimals. So if you want to do decimals, you don't really have to do them, but I need to at least see the fractions and the numbers and these parts here. And that'll make it fun. That'd be cool. All right, so now we have that table done. Now we're going to graph it out. And graphing is the biggest part here. All right, so we're going to do 1, 2, 3. So positive 1, positive 2, positive 3 going up. And 1, 2, 3. So negative 1, negative 2, negative 3. Remember, this is our y-axis right here. Sorry about that. This is our y-axis. So our y values need to go on the y-axis. And then here, this is our x values, our answers for our x's. And this is our x-axis. So that means when we do this, we're going to have to go by like big numbers here to be able to get up to 125. So I'm going to go by 25s here because all my numbers here are getting pretty big quickly. So our x values are now here that are big numbers, and these are our y values, which are the smaller ones. So I'm going to do 25, 50, 75, 100, and 125. And with this again, is up to you how you label this. You choose how the numbers move on the number line. I'm not going to tell you. You have to figure that out yourself and how you want to do it. But they must be the correct increments. They can't just be random increments. They have to be the same. All right, so we already know what the log function looks like. So when we graph this out, it should look like a log function. So let's go ahead and graph these points. So we have here that that 0.008 and negative 3, 0.04 and negative 2, 0.2 and negative 1, 1 and 0, 5 and 1, 25 and 2, and 125 and 3. So that's going to plot those points. So when it comes to that 0.0008, that's going to be really close to that the y-axis here. So when we go down to negative 3, it's going to be like really close there. Really, really close. The 0.4 and negative 2. So 0.4 is going to be like still small, close to that x-axis, the y-axis there, sorry. And we're going to put it right there on negative 2. 0.2 is really still small. We're going to put it right there. And again, with this one, you're just getting it close, like moving it over a little bit more to the right for each one of them because we don't have perfect numbers for that because it's so small. All right, here for 1, and we go to 0. So 1, 0 is about like somewhere in there, something like that. Not exactly, but something like that. Then we have 5, and then go 1. So again, somewhere in there, not perfect at all. We have 25 and 2, and then 125 and 3. And now we just connect the points and make a graph. And it should look like a linear function here. And again, because it's a log function, make sure, and I said linear function earlier, make sure it looks like a log function. But also here, make sure you have your vertical asymptotes here. It's important that that must be there for the log function. If it's not there for log function, then it's going to be kind of wrong and messed up and everything that sort. So have that asymptote. It must be there. And make sure it's visible so I can see it. All right, so again, if this confused you a little bit or you're not really sure about what's going on, watch it again. If that doesn't help, go ahead and call me over because I'm in the room again. Call me over and I'll help you out with this. I'll help you out as quick as possible. All right, talk to you later. Bye.